let's do a quick chat about last class. So last class we learned to, you don't have to write this piece down, but I just want to review this. So let's all look at the board. So last class we learned to find an angle. So like to find an amount, angle, to find degrees. Specifically, you have to do the inverse of your function, of your trig function. So in your calculator, that would look like tan to the power of -1, and then your ratio or the value that was given. We remember this? So whenever to find degrees, you're doing the inverse function. Okay, so today we're going to look at finding lengths of our triangles. So first thing, sometimes you can use Pythagorean's theorem in this. Sometimes you can use trig. Sometimes you have to use Pythagorean's theorem. Sometimes you have to use trig. It depends what's given. So let's just take a second and review Pythagorean's theorem. So it's written there for you. C squared equals A squared plus B squared. I personally only use this one and then I manipulate it. Same thing, just equal signs on either side. You could remember there's the subtracting piece. Our hypotenuse, grade 10s, is always side C, correct? Cool. Do class example A on your own. You all should have calculators with you to help you. It says measure to the nearest tenth. You're all doing this right now. 1A, review Pythagorean's theorem on your own. Go. Pythagorean's theorem. Class example 1A. Everyone's trying this right now. Press second quit at the very top, or second mode, and it should be okay. 4.5. 4.5.
No. I did 2.5 times 2.5. What are you saying right now? That's how you get the square 1/7. Thank you.
So, first step, we all should be always writing down Pythagorean's theorem. We always write our formula. Then we're plugging in our data, or our numbers. So it's 2.5 squared plus 3.7 squared equals C squared. I'm going to show you on your calculator what it looks like, because there are some short kind of quick steps to make it a little bit easier with your graphing calculator, because it stores data, and it makes it so you can like get a more exact answer, because then you can do absolutely no rounding, and that's our ideal, right? We want to round as little as possible. If you have to round during your calculations, you always keep 2 extra decimal places, and then compared to whatever your answer is. So on your screens, you would put in 2.5 squared, and then you right away can go plus 3.7 squared. So you can so then you have to square root that. But your calculator will let you do this. So grade 10s, let's pause for a second though. With your graphing calculators, I want to show you something. So if I put my 2.5 squared in and press enter, that's my answer. Pause. Sorry, thank you. If you right away from here, grade 10s, press plus, it'll include that answer. So then you don't have to rewrite it. Do you see how I did that? Kind of nice. So C squared is equal to 19.94. Then I square root both sides. We're rounding to the nearest tenth, so we get 4.5 centimeters. Try B. On B, 4.5. That's a funny looking 5. Thanks. Andy Love. Camden, stop talking. So then you're going to do the second, and then over the x squared button is your square root symbol. So find x squared, and then in blue is your little root symbol. Okay, everyone try B. I'm going to help Andy. So on B, we're not solving for C. So that's it goes from the
Didn't you just say the hypotenuse is always C?
No.
Yes.
No, if you're going, it's.
hypotenuse is always C.
That's not.
That's why I'm confused, because it looks like C's the.
That's a point.
Oh,
That's the corner. So it's like triangle A, B, C.
oh, I thought.
So 122 is side C. Let's call the 120 side A. So in this is little b. So in this one, I have 120 squared plus b squared equals 122 squared. So on my calculator, I'm going to go 122 squared, and I get 1484. I said that wrong. 148.84. What's 120 squared? So I do 120 squared, 140 400. So then I subtract that. So then b squared is equal to 484, square root both sides. So I get 22. You should put units in your final answer, so 22 millimeters. Go ahead, Charlotte. A and B, it doesn't matter. It's just your two other sides. C is always your hypotenuse. And that's the only thing that matters. So side C is always the side opposite your 90-degree angle. A and B can flip-flop back and forth. Doesn't matter. Okay, turn the page. I'm going to pass out some sticky notes because we're adding in some of my own notes at this point because I think your workbook sucks. And we're going to go add a little bit more there.
What? Why is it? What did you just do?
Just stay afraid. Are they though? I know. I know.
What?
What are you doing with my calculator?
You can type with it. There's a whole
Give me
thing.
my calculator.
It's not pretty. Is that one that's pretty good?
Thank you.
What is it? What are you saying? Can you give me my calculator, please? Why are you stealing my calculator? I saw you.
Okay, so grade 10s. On your first sticky note, you're going to put this title. You're writing fairly small on these. Select, you should have 2 sticky notes. Yeah. So your first sticky note, this is your little title. You're going to put it at the bottom of page 219 over that text. So when we're solving for the length of a side of a triangle, we can use Pythagorean's theorem. Sometimes not enough information is given. So then we're going to have to use trig. To figure out which trig ratio, so sine, cosine, or tan, there's a couple things you need. So we have our SOHCAHTOA. So you're going to need 2 out of 3 pieces. So those are going to be 2 sides because we're talking, sorry, so it could be 2 sides, and then you would use Pythagorean's theorem. It could be 1 angle.
What do you mean, you 2/3 pieces?
I missed the word need. Grade 10s, you need to focus so much more. So you could need 2 sides, and then you could solve. You need 1 angle and 1 side. That's your other option. So then you have to use like process of elimination. So if you have 1 angle and 1 side, you need to see what side are you looking for, or what side do you need. So that's like opposite, hypotenuse, or adjacent. So then what side do you need? So with that in mind, you're going to be able to figure out which trig ratio you're going to use. So if you turn the page to 220, we're going to do that example and like keep this in mind right now. Just turn the page over.
Is that last bit dual?
Oh, you mean what?
It's so messy. So on this example here, first step in every trig problem is really helpful to label it. So this is the angle in question. So the 14.2, this side is my hypotenuse. The x, or the side that we're looking for, is our opposite side. Turn the page, page 220. So I'm going to write out SOHCAHTOA again here. Page 220, right here. So on this one, we're looking for the opposite side. So I'm going to highlight the O's. So right away, I know I have to use sine or tan because those 2 options have my opposite side involved. Then I'm given my hypotenuse. So that's the other piece of information. So there's only one option that has my opposite side and my hypotenuse. So that means we have to use sine to solve this one. Does that make sense how I got there? So you have to go through it part by part. So I'll do that again. So I've labeled my triangle. Do you guys agree with that? No, I'm just labeling it. So I've labeled my triangle. Do you guys see this? Does that make sense? Opposite, adjacent, hypotenuse, how I've labeled? So I need to use a trig ratio to solve for that unknown side that has 2 out of the 3 pieces. So my opposite side, I need to use one that has opposite side included because that's the side I'm looking for. So I have to use sine or tan. Then I have to use the other piece. The hypotenuse is the other piece of information I'm given. Sine is the only one that has opposite and hypotenuse in it. So we're going to use our sine ratio. Right now you don't know how to use it. That's fine. You just have to know how to identify it. Does that make sense right there then? We're going to go through a lot of these. It's okay. Before I teach you how to solve it, I want to review just like manipulating equations. And that's going to be our second sticky note. Just because I can give you another one. You can put this one wherever. Page 219 probably has more space to put it.
Are we gonna do one then?
Yeah. Okay, so if I gave you the equation, how do I want to do this? 2 is equal to b divided by 4. How do I isolate and solve for B? Matt. Cool. So times this side by 4 times this side by 4. So then B would be equal to 4 times 2. Do you guys agree? Right? I'm just manipulating an equation. This is going to come into play later on, and this is why it's important. So in this case, 8 is equal to B. I get that you guys could have just figured that out by looking at it, but we're going to do questions where you can't. So that's why it's important that we're reviewing this. The other scenario that's going to come into play is, say we had 2 is equal to 8 divided by C. How do I solve for C? How do I isolate? Like, what are the steps to solve for C in this example? So we have to multiply by C. So we're pretending here we don't know the answer just by looking, right? Because the questions we come across, you won't. So you times both sides by C. These C's would cancel out. So then my next line is going to be C times 2 equals 8. And then I would divide by 2. All of the questions we're going to do are going to be set up in the same format. Something is equal to like a division statement. So you have to be comfortable with manipulating equations. Is that okay? Charlotte? Because you do have 8C, you totally would have, but you'd have 8C over C still. C divided by C, those cancel out. Right? Anything divided by itself is equal to 1. Good question. Okay, so let's go back to that question now on page 222. So the very first one. So we're keeping those kind of aspects in mind. So in this question, we've already identified we're going to use the sine ratio. So you're going to set it up like they have here. So the sine of 52 is equal to our opposite side x over our hypotenuse. We need to isolate and solve for x. So I'm going to write this to the side because I don't love how they wrote it out. So we have the sine of 52 is equal to x over 14.2. I need to isolate and solve for x. So I'm going to multiply both sides by 14.2. Those two cancel out, so I'm left with just x over here. And then really what I'm going to do is 14.2 times the sine of 52. I want to take a second to show you how you put that in your calculator. So make sure you got that written down and then take out your calculators. So on your calculator, first thing we're going to do sine of 52, press enter. Make sure you get that same thing as me. And then sine 52. Okay, so pause. If first check, we're not doing second sine, we're just doing sine. Okay, second check, everyone with a graphing calculator, press mode. Oh, just kidding, it's my fault. I'm the one that's wrong, guys. And then you press second mode again. My apologies. Okay, sine 52. There you go. You should get 0.788. Is that better?
Yeah.
Okay. So now you're going to press times 14.2. You can do this in one step. Really careful if you have a graphing calculator. If you're doing this by your phone or like just a regular calculator, you have to do it in 2 steps. If you have a graphing calculator, you can do sine of 52. You have to close your bracket. Then you're going to do times your 14.2. You have to make sure you close that bracket though. Regardless, you're going to get 11.2 if you round correctly as your final answer. Because you did it in 2 steps then, and that's fine. On 2 different lines. That's totally fine to not close your bracket. If you do it all in 1 step, just make sure you close that bracket. Why?
Why do we want 2 decimal places?
Because the question said 1 to 1 decimal place.
That's the only reason.
Yeah, that's the only reason.
If you don't know what you should
It will almost always specify.
Fun calculators work with WhatsApp as well.
Oh, I don't know about Android.
I do.
Okay, so perfect. So, okay, we're gonna do a bunch of these guys. So, our final answer here is 11.2. Put units in the end. Centimeters. Let's look back at our triangle. 11.2 should, being our opposite side, it needs to be smaller than our hypotenuse. 11 is smaller than 14, so that's your check that you haven't made some weird mistake. Okay, let's go. Oh, sorry. Yeah. Actually, can you hold and do one more question? Let's try this next one. Really good strategy is to draw a diagram. So a ladder that's 4.5 meters long just reaches the top of a wall. So that means I have a wall here. This would be my ladder. You're all drawing this diagram. So this side is 4.5 meters. The angle, grade 10s, being able to interpret questions correctly is part of the curriculum. So you have to make sure you're reading and interpreting correctly. We will practice that as well as this unit goes on. The angle between the ladder and the ground is 65 degrees. So right here is 65 degrees. This, in theory, is a 90-degree angle. It's a perfect wall with perfect ground. Make a rough sketch, determine the distance between the bottom of the ladder and the bottom of the wall. So we are trying to solve for this side, X. I find it helpful, you don't have to do this, but I find it helpful to first draw a picture that has a little bit of context. So I literally drew a ladder there, right? We're going to get into questions where it's like you're standing on top of a cliff and you're looking at a boat out at sea, and they get really like descriptive. So I find it helpful to draw like a picture diagram, and then let's just translate that to be just a triangle. So this would be just my triangle. I'm going to make that bigger. So here's my triangle. This is my 65. This is 4.5. So now our first step is to label this. So 4.5 is my hypotenuse. This is my opposite side, and this is my adjacent side. Second step, let's write out SOHCAHTOA. So we are given our hypotenuse. So we know right away we have to use sine or cosine, because those are the only two options that have both hypotenuses in it. I am looking for my adjacent side, correct? So that means I have two of the three things there, so I'm going to use cosine. So when I set this up, we then have the cosine of 65 is equal to our adjacent side over our hypotenuse, which is 4.5. I have to isolate and solve for ADJ, or solve for the adjacent side. So I'm going to multiply both sides by 4.5. Those cancel out, so I'm left with my adjacent. Okay, try that on your calculator, see if you can get the correct answer. They tell us the nearest 1/10 of a meter. So I do cosine, not sine, cosine of 65 times 4.5. You should get 1.9. Andy.
So I got the right answer, but I don't understand why you're like dividing.
I'm not dividing.
No, but like if you go back, it's like adjacent half like.
Because my trig ratio originally, so what I wrote in black originally is like the ratio what I would divide to find out what that's cosine of 65 is. So I'm just isolating the like unknown side length. So that's why I multiply both sides by that 4.5. Raise your hand. Did you get 1.9?
Oh. What do you do? Wait, so what do you then do? Cos?
Cos. So you're doing it on your phone though. So I think on your phone you have to do 65 first, then press cos. Then that answer you times by 4.5.
Oh.
This is why you need a calculator. Your phone is not as convenient. There you go. Okay, I hope you guys can do Pythagorean theorem. So I'm just going to cross that off. So now part 2, determine the height of the wall. So now, same triangle. I'm just going to draw mine again. 65. This side is 4.5 meters. Now we need to find our opposite side. So we could do this using the side we just found. I strongly encourage you not to. Reason why is if you made a mistake, then your next answer is going to be wrong. And a lot of these questions build like that. So you always want to go back to the given information if you can. So on this one, if I write out my SOHCAHTOA again, the opposite side, I know I have to use sine or tangent. We're also given our hypotenuse though. So I have to use sine here. So in this one, the sine of 65 is equal to our opposite or our unknown over 4.5. So to isolate and solve for opposite, I multiply both sides by 4.5. Go in your calculators and try it. Yeah.
Where's the piece of my calculator? He threw it. He's lying.
Why does Camel have it?
Because he took it from my desk.
It's really, okay, let's look at our desks right now. Really hard for him to do.
Did you not get up? Yeah, he got up and took it.
Okay, we should get 4.1. Do we all see that with correct rounding, this is 4.1, not 4.0? Yes? Good. So I get 4.1 meters. Yep. Pythagorean's theorem, yes, totally. You spent grades 8 and 9 doing Pythagorean's theorem. I'm going to assume we've got it and we don't need to practice that. That's fine. Totally fine. Totally fine. Okay, turn the page. We're not going to do the Pythagorean's theorem. Okay, so in this question, let's start off, let's label everything. So that's my angle of 64 degrees. Side A is what we're looking for, is my hypotenuse, because that's the side opposite my 90-degree angle. 7.9 is my adjacent side. We don't need this, but just so you're aware, my other side is then my opposite side. So step 1, write out SOHCAHTOA. You could do this in your head for this matter. We are looking for our hypotenuse. So I have to be using sine or cosine. Those are the only two ratios that have our hypotenuse in it. Then the side we're given is our adjacent side. So we have to use cosine then. Okay, so from here, your workbook actually wrote this one out pretty well. So when we fill it in, we're going to have the cosine of 64 is equal to 7.9 over A. we need to isolate and solve for A. And so this is the example we did earlier on our sticky note. I can't solve for A if it's in the denominator. So we're going to start out by multiplying both sides by A. So like I personally would always write it out. So then those two cancel out there. So I get A times the cosine of 64 is equal to 7.9. From here, I'm going to divide both sides by the cosine of 64 to isolate A. So then in your calculator, this is careful. I personally, depending on your device you're using, make sure you're actually doing just the cosine of 64. So you might want to do that one first and then type in 7.9 divided by that answer. Or you can be really careful with brackets. So 7.9 divided by, I would put a bracket, cosine of 64. You don't actually have to close your brackets. And then when you press enter, we get our 18.0. If you're doing this on your phone, you could do the cosine of 64 first, and then go 7.9 divided by that answer.
7.9.
Oops. Oh, I did that backwards. Don't ignore that one. I typed it wrong. So then you would do 7.9 divided by your 0.438. Okay, so you can do it a couple ways in your calculator. Just make sure you're typing it in correctly. Charlotte.
I just got 41.
So when you're using your phone, you put in your angle first. So you would do 64 and then hit cos. So your final answer for this one is 18.0. Okay, I'll come check. I want you grade 10s right now. Try and do class example 4 on your own. Draw it out first.
The one below. Oh, yeah. My side,
It's just like,
yeah, it's just, there's like higher spots than others. It's ice.
Camden, get going. So you're all drawing the picture initially, and then you're solving for, in this case, you're solving for your hypotenuse. Get going. Try this on your own. I should review, remember when they're labeling your triangle, so like PRQ, that R is like really indicating the corner where the angle's at. The middle letter is where that angle is at. So make sure your diagram is the same as mine. So if you draw it wrong, your calculations are going to be wrong, and it snowballs. Yeah?
Mine is the same, but it's just upside down.
That's totally fine. So as long as PQ, like their labeling is matched up, yeah. Generally speaking, your triangles almost like the majority of the time are actually going to be in this orientation. Not always, but like I would say majority. So on this one, we have to be using sine, correct? Because we're given our opposite side, we're looking for our hypotenuse. So sine, our so, has our O and our H. So now we need to isolate and solve for our hypotenuse. We start by multiplying both sides by our hypotenuse, because then they cancel. I'm going to just show a lot of steps here. So then I would be left at this point, and then I'm going to divide by the sine of 28. And then oops. So these cancel. So what you're actually going to be putting into your calculator is going to be 15.6 divided by your sine of 28. When you do that, you're going to get 33.2. Raise your hand if you got that one on your own. Good. Good. Okay, let's try this next one. You guys okay for me to move on? Yeah. Pictures given to us. So determine the lengths of AB and AC. So we're going to do two different things here. So maybe split it like down the middle so you have enough space. So the first let's solve for AB. So let's talk about our notation. Let's put a little title. That's going to help make this a little bit more clear. So we're given 71 degrees. So that makes our 147 our adjacent side. This is our opposite, and then our hypotenuse. To solve for AB, we have adjacent and opposite. So which ratio do I include adjacent and opposite? Tangent, good. So I get the tan of 71. So this is SOHCAHTOA. So we have opposite over your adjacent side. So then I'm going to leave opposite. You can leave opposite as OPP, or you could plug in AB, up to you, over 147. How do I solve just for my opposite side then? Good. So then I'm going to times both sides by that 147. Try it on your calculators. And they said to the nearest meter. No, tan of 71 times 147. So you should get 427 meters.
That means you probably did the negative 10.
Yeah.
No. Make sure you're not in radians. Make sure you're not in radians. So it's the little word on the top. There you go. Andy. Pardon? So if I go back to SOHCAHTOA, I have my adjacent side, so I know I have to use cosine or tan because those both have adjacents, and we're looking for our opposite. Okay, so now we need to find our hypotenuse. So to find our hypotenuse, which is AC, there's a lot of options. You could use Pythagorean's theorem, totally. I have two sides, I can solve for side C. You could use cosine because we have our adjacent side, we're looking for a hypotenuse. You could also use sine because we just found our opposite side and our hypotenuse. I'm going to say let's go through cosine because one, you guys should know how to do Pythagorean's theorem, and two, we need to practice with trig. If it was up to you, like this was an assigned question, do whatever your heart desires. Let's go through cosine because that's our most unfamiliar. So we're going to have the cosine of what? What's my angle? Good. So the cosine of 71 is equal to our adjacent side over our hypotenuse. So filling that in, my adjacent side is 147. We don't know what our hypotenuse is. So I have to isolate and solve for our hypotenuse. So I'm going to multiply both sides by hypotenuse. Then I am left with like hypotenuse times the cosine of 71 equals 147. Divide both sides by the cosine of 71. I am showing a lot of steps to really emphasize why this is the process. You can show less steps. So then on your calculator, it's 147 divided by the cosine of 71. When you do that, we get 152. Sorry, 452 meters. Okay, I want to pause for a second while I have you because this is going to be a little bit easier in person before you start doing some work. So I mentioned this yesterday. So there's two types of ways you can measure degrees. Just like there's two ways you can measure like the length of something, right? We can use centimeters and inches. With degrees, you can use degrees or radians. Grade 11, you're going to learn about radians. So it's just a different unit of measure. Good catch. You have to use our trig functions in degrees. So if you have a graphing calculator, I want everyone to press mode. So that's on the top left. This screen's going to pop up. So if you have a graphing calculator, press mode. So on my screen, you can see on the left side, it's in red. It highlights the last button I pressed. So mode on the top left, beside your shift key or your second key. Are you all here? So here on the third row, I guess it's the fourth row. This is like titles. See how the word degree is like blocked off? That needs to be blocked off. Say, everyone look up here. Say you had, though, the word degree, radian was in black. That's why your answers are going to be wrong or really wonky. So that's what Gavin just had when he got a negative answer, is because he was in radians. So what you do is use these keys, like your cursor keys, go down to it. See how mine's flashing right now? Make it so it's flashing over the word degree, and then all you do is press enter. And then that'll change your units. You always want to make sure you're in degrees. What often happens with your graphing calculators, though, is they get reset or cleared. It automatically defaults to radians. So you need to be aware to make sure you're always switching back to degrees. It's used, like, it's just a different unit measure. It's easier to graph stuff in radians. And then to leave this screen, you're going to press that second button and mode again. And then see how it says quit on like the back of your calculator beside the word mode? That's what it means. Second quit. Okay, so we have 12 minutes left in class. We are going to try some practice questions here.